Assalamualaikum and good morning. So, as I promised, I'll be preparing a YouTube on how to solve the example for the velocity analysis. Okay, we are going back to the first example, which is the sewing machine linkage. Just to show you the steps taken. I hope I can do maybe 2 or 3 examples in this video. Okay, now first we have to understand that in this part, this is a crank slider problem where this wheel is basically act as a crank, and then this connecting to connecting link, and it will drive the needle here. So given that the angular velocity is 200 rpm, that means the rotational speed is 200 rpm counterclockwise, then we need to find, in this case, what will be the velocity of the needle at this point. So the first thing is, of course, to draw the kinematic diagram. So let's draw it according to what given here. So I will just follow how to draw this part. Okay. As usual, I keep mentioning that you have to have a reference line. So in this case, something like this, and make this as the point A. And now this is in 15 mm and 30 mm and so on. So you know that when it's 50 mm is 1.5 cm and then 3 cm. Is it appropriate? So you can actually have a bigger scale to help you draw this part. So in this case, I will be taking so what's the best, 50 mm, 10 mm, 1 cm, maybe 2 cm. 2 cm equals to 10 mm. So therefore, if it is 15 mm, will be equivalent to 3 cm on paper. Is it 30 mm, will be equivalent to 6 cm paper. If it is 8 mm, but what should be 1 point yeah, 1 point my math is a bit rusty here. 5 okay, 1.6 cm. Right, now with this, first we have to measure the angle. Okay, let's just make it one straight line here. 90 degrees down. Then we create a line down. So this is 30 degrees to vertical. Okay, so we measure 30 degrees. That's 30 degrees. So in this case, it is 3 cm. Of course, this is not, we try to be as much as possible accurate. This one should be, the offset will be 1.6. Draw another line. Okay, now the length here, the length of the connecting link is 30 mm. So now we have to draw it using the compass, which is 6 cm. Draw something like this. So this will be the point for the point C. So this is A, B, and then C. Right. Of course, we can just draw a block somewhere here. Okay. Right. Now we have been given the angular velocity. Right. The rotational speed, which is omega 1 equals to 100 rpm. So therefore the angular velocity should be 20.9 radian per second counterclockwise. Okay, maybe in that direction. So VB now will be perpendicular to link AB or link 1. Right. So we can basically get the direction here should be 90 here, right? So BB should be in this direction, right? BB, and we can calculate, okay, VB, based on this slide again, VB is equals to omega 1 RBA, which is equals to 20.9 times 15 mm, so it's equals to 314 mm per second. Right. Okay. Now we have this direction already. Then we need to identify what will be the. This is just a draft, just sketch. But we know that this is 30 degrees. This is 90 degrees. So this is 60 degrees. So this one will be 30 degrees. Right. So basically this is 30 degrees in this direction. So what we can do, actually it's my mistake to actually draw it in the middle. It should be just slightly there, so it will be easier for me to draw the rest of the things. Okay, let's just draw somewhere here lah. Right, over here we can start and check. This is starting point. This is 30 degrees to horizontal. So again, this part 30 degrees to horizontal. Okay, now choosing the scale. The best thing is actually to enlarge the scale. For example, in this case, whether you want 314 mm, you can use also, which is in the actual scale is 31.4 cm, but it's too big. So you can make it smaller. You can use 3.14 cm, or you can use 6 to 8 cm. Depends on you. But since I'm drawing on the same page, if you are answering your exam, make sure you draw it completely on a new page. So in this case, I just choose 3.14 cm. Okay. 3.43 so this is 3 point something like this so it's not that accurate if you choose my method, but anyway, okay, this is the direction. Now we actually need to find where is the VC, right? So VC is basically going downwards, right? So here the VC should be going all the way down. Okay, let's just draw a line first. Okay. So this is just VC, this is the VC direction, and since this is an absolute velocity, it will start from one single point here. This is BB. So what we need is a VCB, right? VCB. So VCB is basically at 90 degrees to the link 2. This is link 1, this is link 2, 90 degrees. So we need to find the angle there. Okay. How to create that? This is point C. I see. Right. So either way, but you know that actually it will be this direction. Why? Because it will be continuing from here. If it is going to this side, it will go on that side. No way, it will not meet this VC. So now we have to find the angle of this now. How to do that? Measure it lah. No, this is a vertical line. The easiest is to measure from the vertical line. Okay, now you see, in my case, my protractor is too big, so I need a longer line actually to be able to measure it. Oh. Okay, the easiest is actually just to measure this part, this angle. Okay, much easier lah, I think. So because you're already there and I have this part 90 degrees. Alright. What will be the angle there? Okay, looking at here, this 90 degrees. This is 10, 20, 30, 40, 50, 60. 60 lah, it's about 60 degrees because I have been inaccurate somewhere, so this is basically 60 degrees. So, and of course this is 60 degrees. Now if we actually draw a straight line from here, okay, I know this is tedious, but this is how it's been done. Okay, or yeah, depending on how you want to do it, but this is 90 degrees. Okay, this point degrees, then you measure the 60 degrees, right? Yeah, sorry, this is 60 degrees. Where's the 60 degrees? 1, 2, 3, 4, 5, 6, okay. Alright, now we have the 60 degrees line. Now we can draw this now, like this. So basically this is VC. This is VCB. So how I want to find the value? Measure. Okay. This is what? 3.12. about 330 millimeter per second. BCB is 320 millimeter per second. Of course, it depends on how you solve. How you draw it. Let's check the answer. Okay, by measuring. Okay. Short a little bit. So the actual answer will be 335 millimeter per second. BCB is 330 millimeter per second. If you actually improve your drawing, you get closer to this answer, but unfortunately in my case I'm not really doing it exact, so this will be the answer. So that's how you want to plot the velocity, how you want to do the velocity analysis. Thank you. I'll probably produce another solution later on. Thank you. Assalamualaikum.